So welcome back, Stella. We're going to finish with these two other exercises. These two, the F and the H. We're going to do the G. So the F says tan x being equals to root 3. Okay, let's try to solve it. We have tan x being equals to root 3. So since there is already tan here, I'll do everything possible to be in this form, tan y being equals to tan x, for me to use the general solution of tan. Is that okay? So I'll write this back as this implies, or it's implied by, tan x would be equals to what? Tan of what? Tan inverse of root 3. Is that okay? Tan of tan inverse of root 3, because I know that the tan of the tan inverse of a number must be equals to that number. Is that okay? So let's then find the tan inverse of root 3. So if you use the trigonometric table that I taught you of basic trigonometric angles that I gave you when last time, or you use your calculator, you will see that since the tan inverse of root 3 is equals to 60 degrees. 60 degrees is the same as pi on 3. When you do the conversion, pi on 3. Is that okay? The same as pi on 3. So it implies, or it's implied by, I'll replace this tan inverse of root 3 by what? Pi on 3. So this implies tan x will be equals to tan of what? Pi on 3. Is that okay? Okay, very good. Now we are already at this level. Let's go back to the general solutions. We saw when we're giving general solutions of tan that tan y equals to tan x if and only if the first condition is that this has a solution. For this to have a solution, we first need to put conditions we first need to put conditions on y and x. Y and x must not be equals to odd multiples of pi on 2. That is, y must not be equals to what? Pi on 2 plus k pi, or x must not be equals to pi on 2 plus k prime pi, where k and k prime belong to z. Is that okay? So that's the first thing we have to verify before giving the general solution. So this is the 9th part. We notice that since pi on 3 is not an odd multiple, is not equals to pi on 2 plus k pi, as the general solution states here. The general solution, for you to use the general solution here, this x and y must not be what? Odd multiples, must not be odd multiples of pi on 2. And we see that pi on 3 is not an odd multiple of pi on 2. You get what I'm saying? It's not an odd multiple of pi on 2, because for it to be an odd multiple of pi on 2, if you do pi on 3, look at something. For you to check that, just do pi on 3. Just do pi on 3 minus pi on 2. If it does not give you a multiple of pi, then it's not a multiple, then pi on 3 cannot be written in the form pi on 2 plus k pi. Is that okay? If you do pi on 3 minus pi on 2, what do you have? You're going to have 6 divided by this, I'll have 2 pi minus 6 divided by this, I'll have 3 pi. This is equals to minus pi on 6, which is not equals to what? K pi. Because this difference must give us, if I bring this pi on 2 here, the difference must be equals to k pi. If it is not equals to k pi, then pi on 3 cannot be written in this form. Is that okay? So that's the simple logic. So let me take the pen. So since pi on 3 is not uh, 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 an odd multiple of pi on 2, this is what is this is how we write it. Since pi on 3 is not equals to pi on 2 plus k pi, it implies, or it's implied by the general solution of this equation here, we are at this level. It implies, or it's implied that y, the general this x, the general solution will be equals to what? Since x, wait, let me wipe this. Let me wipe this. Let me wipe this. So we are at this level. We know that the general solution of this must be in such a way that, first of all, this x must be different from what? Pi on 2 plus k pi. Is that okay? Or this pi on 3 must be different from pi on 2 plus k pi. That's the first conditions we have to bring out. Is that okay? Our x must not be equals to an odd multiple of pi on 2. And we also see that our pi on 3 must not be equals to an odd multiple of pi on 2. Is that okay? Must not be equals to an odd multiple of pi on 2. And this is true. This is true because pi on 3 cannot be written in this form. This is how we prove it. You just do pi on 3. You do this pi on 3 minus, when this pi on 2 comes here, minus this pi on 2. Is the result giving you a multiple of pi? No, the result is not giving you a multiple of pi. This is how you test it in your rough work. So x different from pi on 2 plus k pi, or pi on 3 different from this. With x, the general solution, this x will be equals to what? This pi on 3 plus k pi. So that's our general solution. So with k, don't forget that this is k prime. Yes, this is k and k prime. With k and k prime belonging to z. So the general solution on R S will be equals to what? Any number of this form, pi on 3 plus k pi, with k belonging to what? K belonging to z. So that's our general solution. That's our general solution. If you are to give it in terms of degrees, it simply means S, the general solution will be what? Pi on 3 is simply 60 degrees plus k plus 180 degrees k. So that's it now. 180 degrees k with k belonging to the set of integers. Simple. Is that okay? So that's the general solution. So let's do the last one. Where is it? Let's do the last one. Okay, let's continue. I wanted to mention something here on the conditions here. You call this k prime. Yes, you call this k prime too. Yes, you're going to call this k prime. X must not be equals to pi on 2 plus k prime pi, or pi on 3. Pi on 3 must not be equals to an odd. This is an odd multiple of pi on 2. X must not be also be equals to an odd multiple of pi on 2. Is that okay? So and the general solution, our x must be equals to what? This x, which represents our y when we are solving, tan y being equals to tan x being equals to tan x. This part will be equals to pi on 3 plus k pi. Is that okay? So that's the general solution. Okay. Now let's go to the next question. Or you can differentiate even this. You can call this k second prime. You can add the second prime here, where k, let me take a dust. Let me take this, where k prime and k second prime belong to the set of integers. Is that okay? Okay. This is simply to differentiate this and this. Is that okay? So they must not be equals to odd multiples of pi on 2 for this equation. So for this to have a solution, x and pi on 3 must not first of all be equals to odd multiples of pi on 2. From there, after putting the condition, we then put the general solution, which is x being equals to pi on 3 plus k pi, as the general solution of sine states, of tan states. That's it. I hope you get what I'm saying. So I'll call this even k second prime. Yes, I'll call this k second prime with k second prime belonging to the set of integers. Is that okay? Okay, let's go to the next question. The last question, we're going to solve tan 2x being equals to tan 3x. Okay. Let me go to the paper. So we have to solve. This is letter, which letter? This is letter H. Letter H. We have to solve tan 2x being equals to tan 3x. Is that okay? Okay. Okay. Let's solve this. You know that this can be written back as tan 3x being equals to tan 2x. It's the same thing. You understand? Now, it's already in the form tan y being equals to tan x. Is that okay? So, this has a solution. This has a solution. We first need, when we are solving for tan, we first need to put the condition of existence of the solution of that equation. So, for this to have a solution, the first thing is what? 3x must be different from what? Pi on 2 plus k prime pi, or 2x must be different from what? Pi on 2 plus k second prime pi. Is that okay? Now the general solution will be what? 3x being equals to 2x plus k pi. Is that okay? Where k prime and k second prime belongs to what? The set of integers. Is that okay? So this is what, let me go back for us to verify things. This has a solution if and only if you first put the condition on y must be different from pi on 2 plus k. This, it depends on you. You can decide to put k, you can decide to call this k, you call this k second prime, and here you call this k prime. Depends on you. You understand? So you put the condition on y, the condition on x, and then you write the general solution. The general solution, which is y, this being equals to this plus k pi. Is that okay? So let's go back. So we are here. So yes, we are here. So this implies, or it's implied by here, it simply means that x must be different from what? When I divide all through here by 3, x must be different from pi on the 6 plus k prime pi on the 3, or x must be different from what? Or x must be different from pi on 4 plus k second prime pi on the 2. Is that okay? Is that okay? And here we're going to have what? This x, this 2x come back here. We're going to have x being equals to what? K pi. where our k second prime, and k first prime, k second prime belongs to what? The set of integers. Is that okay? From there, we can already write the general solution. Is that okay? So this implies, or it's implied by what? The general. So it implies the general solution on R S will be equals to what? The solution is what? Any number of this form, k pi, such that k belongs to what? The set of integers. So that's the general solution. So you are going to do the other questions. So you are going to do what I left. You are going to do this and this last one. Is that okay? Exactly as we did the other ones. Now let's start these other questions. We're going to do these 3 questions. So here they are asking us to resolve. They have given us a precise interval on which we are to resolve these questions. So here is the approach for you to solve. When they give you a precise interval on which you are to solve, what you are to do is that you first find the general solution. After finding the general solutions, you are going to find the values of k's that will be valid on this interval, and from there you will deduce the answers, the solutions to this on this interval. I hope you understand what I'm saying. So let's go directly into exercises. Let's go directly into exercises. So I'm going to solve I'll solve this first one. I'll solve I'll solve this first one. I'll solve which one again? I'll solve, let me see. I'll solve okay. I'm going to do, as I said, this first one. I'll do this second one, and you have to do the last one as assignment. So let's start with the first one. We have to solve sine 3x being equals to cos x minus pi on the 6. Okay, so I'm to solve exercise 2. Exercise 2, question A. Yes, that's question A. So we are to solve this on the interval minus pi sine 3x being equals to cos x minus pi on the 6. Is that okay? Sine 3x being equals to cos x minus pi on the 6. So we are in this exercise, we are to solve it on the interval minus pi. So this is simply the same as if we convert this in degrees. This is minus 180 degrees, 180 degrees. This is simply on the interval they are asking us to solve it. Is that okay? Okay, now to solve this, you notice that there is a sine here, there is the sine function here, and there is the cos function here. So we cannot use either the sine or the cos general solution. For us to use it, we have either to transform this. We can either decide to transform this using trigonometric transformations, or we transform this. When I'm talking of trigonometric transformations, I'm talking of transforming cos theta into sine theta, or transforming cos theta into sine, and transforming sine into cos. You get what I'm saying? So recall. So what I will do is that I'll instead transform this other side. Is that okay? I'll instead transform this other side. So recall that the sine of theta is always equals to the cos of pi on 2 minus theta, where pi on 2 is 90 degrees. Is that okay? So I'll apply it to this. So this implies sine 3x will be equals to what? Cos of pi on 2 minus the 3x. Is that okay? So we're now going to substitute this inside here. So it implies, or it's implied. So this implies, I will substitute where I see sine 3x, I substitute by this. So I'll have cos pi on 2 minus 3x will be equals to what? Cos x minus pi on 6. You could still decide to transform instead this one, that is cos x minus pi on 6. This is the whole angle, will be equals to what? Sine of what? Pi on 2 minus the whole of this angle, x minus pi on 6. So it depends on you. You understand what I'm saying? It really depends on you. Use any approach that you think favorable. So from here, we're already in the form what? Cos y being equals to what? Cos x. We're already in that form. So the general solution of cos, we know that when we are in this form, the general solution of cos is what? The general solution of cos is y being equals to x plus 2k pi, or y being equals to what? Minus x. So x plus 2k pi, or minus x plus 2k pi, where k belongs to z. That's the general solution of cos. I'll just apply it here. So this implies, or it's implied by, this is equals to this if and only if. This also means if and only if. So this will be equals to this if and only if I have what? Y, no, not y. If and only if our y here is this and our x is what? The whole of this. This is equals to this if and only if pi on 2 minus 3x is equals to what? Is equals to x minus pi on 6 plus 2k pi, this first one, or pi on 2 minus 3x is equals to what? Minus of this whole angle. So minus what? X minus pi on 6 plus 2k pi, as this other one says, with k belonging to what? Z. Very good. So this implies, or it's implied. So I even forgot to tell you something. When you are, as I said, when you are solving this on an interval, the first step is to what? The first step 1 is to finding the general solution. You first find the general solution. So that's it. Let me underline this. Finding the general solution. We are first finding general solutions. After finding general solutions, we are going to find the satisfying values of k's that will give us solutions on that interval. So this implies, so it's implied by, I'll bring the x, I'll bring this x here. Okay, now we are at this level. So here I'll bring the x here, and the pi on the, and the pi on 2 on the other side. So this implies, so it's implied by, we're going to have minus 3x minus x being equals to minus pi on 6 minus pi on 2 plus 2k pi. Okay. Okay. Or I'll bring, this will make minus x. When the minus x comes here, we're going to have minus 3x plus x being equals to this pi on 2 goes on the other side. This minus and this will make pi on 6 minus pi on 2 plus 2k pi, with k belonging to the set of integers. Is that okay? Now, minus pi on 6 minus pi on 2. Minus pi on 6 minus pi on 2. This is 6. 6 minus pi. 6 divided by this goes 3 times. Minus 3 pi. So you have minus 4 pi on 6. Is that okay? So this implies, it's implied by, let me calculate directly also this pi on 6 minus pi on 2. So 6 divided by this 1, I have pi minus 6 divided by this 3 times, this is 3 pi. So I'll have minus 2 pi on 6. Is that okay? So I'll have minus 2 pi on 6, which is basically minus pi on 3. So here I'm going to have minus 4x being equals to, this gives minus pi on the minus 4 pi on 6. Yes, minus 4 pi on 6. Minus 4 pi on 6. Minus 4 pi on 6 plus 2k pi, or this will give minus 2x being equals to minus pi on 3 plus k 2k pi. Is that okay? With k belonging to the set of integers. Okay. Now, this implies, or it's implied by, I will divide all through here by minus 4. So I'll have x being equals to, this gives this will give, when I divide by minus 4, I'll have here pi on 6 plus minus, you have minus here, you have minus 2, you have 2k pi on the minus on 4. When I divide, I'll have here 2 here 2. So this will give k pi on the 2. Is that okay? So this x will also be equals to O. Here I will divide my minus 2. So I'll have pi on the 6 minus what? Minus k pi. Is that okay? With k belonging to the set of integers. Now, look at something. K is an integer. Look at something very well. K is an integer. That means an integer is what? Is both a positive and a negative number. That means the minus here, there's no need of leaving that minus. You get what I'm saying? Even here, there's no need of leaving this minus. If there were minus here, you just leave the minus here. But for the minus that are in front of this k, since k is an integer, you get what I'm saying? Since k is an integer, there is no need of leaving minus here. You can just leave a plus here. So this will be equivalent to x being equals to what? Pi on 6 plus k pi on 2, or x being equals to what? Pi on the 6 plus k pi, with k belonging to the set of integers. I hope you are understanding what I'm saying. Since k is an integer, look at something. Look at something. Let's check these two solutions. When you come and when you substitute k being equals to 1 here, you have what? You have minus pi on 2. Is that okay? You have pi on 6 minus pi on 2. Is that okay? When you substitute k being equals to minus 1 here, you still have what? You still have the pi on 6 minus pi on 2, which was here. So there is no need of leaving this minus in front of this k. You add, you simply put a plus. Is that okay? The same thing here. For here, if there was a minus here, we'll leave the minus. Is that okay? The condition only applies when that minus is in front of k, since k belongs to the set of integers. So our general solutions. So we have already our general solutions. So the general solutions on R of our equation S is equals to what? Any number of this form, or this form. Is that okay? Where k belongs to a set of integers. So we have pi on 6 plus k pi on 2, comma, pi on 6 plus k pi, where k belongs to the set of integers. We have already the general solution. After finding the general solutions, we then have to find what are the values of k, because you guys are fond of just coming and substituting k, any value of k. You just start when k equals to 0, that's not how you do things. When you are being given an interval, this is the interval on which you are asked to find the solution. That's not how you substitute k. You have to find the intervals of k that will satisfy. You have to find the exact values of k that you have to substitute. How do you then find the exact values of k? The step 2, finding the exact values of k for us to have solutions on the interval, or finding the exact values of k, that give solutions. Yes, that give solutions on the interval -pi pi. Okay, let's proceed. We know that the general solution, it is either any number of this form with k belonging to z. Is that okay? So let's take the first form. Okay, don't forget that our general solution here was values of x. Is that okay? Okay, we take the first one. For x being equals to pi on 6 plus k pi on 2. Let's find what will be the constants of k. What will be the values of k's that will give solutions on this interval? Okay, for this, we know that x is on this interval. Recall that x belongs to what? X belongs to the interval -pi pi. That is x must be what? Strictly greater than -pi, but strictly and less than or equals to what? Pi. Less than or equals to pi. Is that okay? I'll then take this x, this first thing, this x, yes, this is our first x. I'll come and substitute it here and make k the subject. So this implies where I see x, I substitute this first one. Pi on the 6 plus k pi on 2 must be what? Greater than -pi, but strictly less than what? But less than or equals to pi. Okay, we have pi on both sides, so we can divide all through by pi. If we divide all this inequality by pi, because there is pi here, pi, you understand? If we divide all through by pi, all the pi will go. So this implies -1. So we're going to have 1 on 6 plus k on 2 strictly greater than what? Minus 1, but less than or equals to what? 1. Is that okay? Now, our aim is to have just k inside here. So how do I for me to stay with k here, I first need to subtract what? What do I do? What do I have to do next? What I have to do next is what? I need to subtract 1 on 6 on both sides of this inequality. So this implies I'll have minus 1 minus, pardon, let me wipe this. So I'm going to have minus 1 on 6 less than, I'll have this, I'll also subtract this, I'll also subtract 1 on 6 from this. So 1 on 6 plus k on 2 minus what? 1 on 6 less than or equals to 1 minus 1 on 6. Is that okay? That does not change the inequality sign. Even here, when we divide it by pi, pi is a positive number, so it does not change the inequality sign. Is that okay? So this implies this will give this times this, it gives minus 6. With this, we're going to have minus 7 on 6 less than, this will go, we're going to left with k on 2 less than or equals to what? This times this, I'll have 6. So I'll have 5 on 6. Is that okay? Now, what are we supposed to do to have k just here? I'll do what? I'll multiply all through by 2. Is that okay? I'll multiply all through by 2. When I multiply all through by 2, it will not change the inequality sign because this 2 is a positive number. So I'll have minus 7 on 6 times 2 less than k on 2 times 2 less than 5 less than or equals to less than or equals to 5 on 6 times 2. Is that okay? So we see that this implies our k must be what? Strictly greater than, if I did this and this will go, I'll have minus 7 on 3. Is that okay? But less than what? This is k. But less than or equals to what? Less than or equals to 5 on 3. So the values of k we are to substitute, here must lie in which interval? They must be integers between what? Minus 7 on 3 and 5 on 3. When you divide minus 7, this implies k must be strictly greater than minus 7 divided by 3 is what? Let me do the division. So 7 divided by 3, this will give minus 2.33 less than or equals to 5 divided by 3. When you do 5 divided by 3, that's 1 point something. 5 divided by 3, use your calculator, it gives you 1.67. Okay. Now, the question you are to ask yourself, what are integers? What are the integers? An integer is either a positive whole or a negative, a positive whole or a negative whole number. Is that okay? So what are the integers between minus 2.3 and 1.6? If I draw my number line like this, this is minus 2.3 and this is 1.67. If this is 0, I know that after 0 I have minus 1 and I have what? Minus 2. Is that okay? Here I will have only 1. Is that okay? Is that okay? Yes. So what are the integers we are supposed to take? So from this, it simply implies that k must be equals to what? K must take which values? Minus 2. K must take the value minus 1 and take the value. Don't forget that 0 is an integer. They did not say k belongs to the set of integers, but not the set of integers different from 0. So 0 is also included. We have 1. So that will be the values of k that we are going to substitute where? Inside here. You get what I'm saying? Let's do for the next one. So from here, we can even proceed here. So we know already exactly the values of k we are to substitute. So when k equals to -2, let's start. When k equals to -2, we substitute it inside here. Is that okay? We're going to have x will be equals to pi on 6 plus -2 pi on 2. Is that okay? Because our k is -2. So when we substitute, I'm substituting values here. I'm substituting values in this one. So this will give this, and this goes. So this will be equals to pi on 6 minus pi. This is simply equals to -5 pi on 6. Very good. Now, when k is equals to -1, we have x being equals to pi on 6 plus -pi on the 2. Is that okay? This will be equals to pi on 6 minus pi on 2. So this will be equals to 6. 6 divided by this, go once, which is I'll have here pi. 6 divided by this, it goes once, minus 6 divided by this, it goes 3 times. 3 pi. This will be equals to minus 2 pi on 6, which is equals to what? Minus pi on 3. Is that okay? So that's the next. When k is equals to 0, what do we have? X will be equals to pi on 6 plus 0 pi on the 2. Is that okay? So this will be equals to pi on 6. Is that okay? Then the last one, when k equals to 1, we're going to have x being equals to what? Pi on 6 plus 1 times pi on 6, which is equals to 2 pi on 6, which will be pi on 3. Is that okay? That will be pi on 3. Okay. No, there is an error here. It's on 2 here. So this is 2. We're going to have, let me wipe this and wipe this. So we're going to have pi on 6 plus pi on 2. So this will be equals to 6. 6 divided by this, I'll have pi plus 3 pi. This will be equals to 4 pi on 6. Is that okay? 4 pi on 6, which is equals to 2 here. It gives 2 pi on 3. Is that okay? Yeah. Let me go back and check something. Let me check something. Okay, it's okay. So you see now that you easily know the values when you use this approach. You easily know the values of k that you will have to substitute. So we have already finished with this first one. Where is the first one? We are finished with this first one. We have to do the same thing for this other one. Okay, we are finished with it. So it implies, so we know already, so it implies for x being equals to pi on 6 plus this first one, for x being equals to pi on 6 plus k pi on 2 plus k pi on 2, comma, the solutions on the minus pi are the solution. S1 are what we had. This first one, the first one is minus 5 pi on 6. The next one is what? Minus pi on 3. The other one is pi on 6, and the last one is what? 2 pi on 3. Is that okay? Okay, very good. Let's now do for the other one. For x being equals to, this is the other one. The other one is this, pi on 6 plus k pi. For x being equals to pi on 6 plus k pi. Okay. Recall, let me underline it. Recall that x, in the exercise, it was said that x belongs to what? Recall that in the exercise, it was said that x belongs to minus pi. Is that okay? We were asked to solve things in this interval. X belongs to this. That is, x is what? Greater than, strictly greater than minus pi, but less than or equals to pi. So this is my x here. I'll come and substitute it here. So this implies pi on 6 plus k pi will be what? Strictly greater than what? Minus pi, but less than or equals to pi. So we are finding the values. We need to find the values of k. So this implies I'll first divide all through by pi. Is that okay? Since there's pi common everywhere. So I'll have here minus 1. And here I'll have 1 on 6 plus what? Plus k. Is that okay? Less than or equals to 1. Now, for k to remain alone here, we have to subtract 1 on 6 from every part of the inequality. So this implies minus 1 on 6, minus 1 minus 1 on 6, 1 on 6 plus k minus 1 on 6 less than or equals to 1 minus 1 on 6. Very good. So this implies here the 1 on 6 will go. So I'll have here k strictly greater than what? I'll have minus 7 on 6 less than or equals to what? I'll have here 5 on 6. Is that okay? So the integers that satisfy, that will give us solutions, are between this interval. What is 7 divided by 6? Let me use my calculator. 7 divided by 6. 7 divided by 6 is 1.17. So our k will be between 1 minus 1.17 and less than or equals to what? Less than or equals to wait, let me see something. Less than or equals to 5 divided by 6, that's 0 point something. 5 divided by 6, that's that is 0 0.83. Is that okay? Now if I draw my number line, this is minus 1.7 and here this is 0.83. This is already a number greater than 0, so I can put my 0 somewhere here. 0. What number? This is minus 1, because this number is greater than minus 1, and my minus 2 will be here. So here, after this number, I'll have the whole number 1. So what are the integers? This is the interval that's concerning us. Open here and close here. Is that okay? What are the integers? What are integers present here? What are the whole integers present here? We have -1 and 0 only. Is that okay? So we shall conclude by saying that it implies our k here must be equals to what? -1 and 0 only. So we shall only substitute -1 and 0 here. So when k equals to -1, what do we have? We substitute it here. I have pi on 6. I'll have x being equals to pi on the 6 plus -1 times pi all over. So I'll have, wait, let me take the eraser. So when I go back here, when I substitute -1 here, I'll have pi on 6 minus pi. So this will give pi on 6 plus -1 times pi. This will be pi on 6 minus pi. This is equals to -5 pi on 6. Is that okay? When k is equals to 0, our x will be equals to what? Pi on 6 plus what? 0 into pi, which is equals to pi on 6. So our S2 will be equals to the solutions will be, so the solutions, so we write the same thing that we wrote here. So for x being equals to c, the solutions on pi are, so for x being equals to, this is our x, pi on 6 plus k pi. For x being equals to pi on 6 plus k pi, the solutions on the minus pi pi, the solutions of on minus pi pi are S2 being equals to what? -5 pi on the 6 comma pi on 6. Now we have to give, after finding all this, the last step now, step 3, we have to give the solutions on the minus pi pi. The solution s on minus pi pi will simply equals to S1 union S2. Is that okay? Because remember that when we're finding when we're finding the general solution, what is the word that's always found? What's the word that's always used here? Or means union. You get what I'm saying? So S1, what was our S1? Our S1 was this, -5 pi on 6 minus 3 pi on 3 pi on 6. Okay, we have -5 pi on 6 minus pi on 3 minus pi on 3. We have pi on 6 and 2 pi on 3. Pi on 6 and 2 pi on 3 union what? What is S2? Our S2 is -5 pi on 6 comma pi on 6. You then do the union between this. This is a set, this is a set. You see that there is already pi on 6 minus pi on 6 that's common here, and pi on 6. So this implies the general solution. The general solution. So it implies, let me write this. The general solution implies the solution on the minus pi is S being equals to what? the union between this. So I'll have minus 5 pi on 6, comma, I'll have minus pi on 3, and I'll have pi on 6, and finally 2 pi on 3. So that's our solution. That's how we find a solution on a particular integral, on a particular interval. So how are you supposed, if you are asked to solve a trigonometric equation on a particular interval, the first thing you have to find the general solution first. After finding the general solution, you have to find what? Because this, the first step was what? Finding the general solution of this. After finding the general solution, you have to find the exact values of k that will give the solutions on this interval. This was our general solution. You take this first one for x being equals to this general solution. You find the values of k that you need to substitute inside here for you to find the values that satisfy this interval. And how do you find it? You first know that in the exercise, it was said that what? In the exercise, it was said that recall that x belongs to minus pi pi. That is x must be strictly greater than minus pi but less than or equals to pi. But our x is what? This. I come and substitute this where I see x. I substitute it. Now my aim is to arrange things in such a way that I have only k. I have an interval of k. You get what I'm saying? So from here, the first thing to do is to go away with the pi's, because there are pi's everywhere. So we divide all through by pi's. The pi's goes. The next thing, if I want to have k alone here, the next thing I have to do is to subtract from every part of the inequality this 1 on 6. So that's why I subtracted it from each part, and you have this. The next thing you have to do for you to just have k standing here, I need to multiply all through by 2. You get what I'm saying? And don't forget that if you multiply by a negative number, the inequality sign will change. Don't forget that if you multiply by a negative number, the inequality sign will change. So here, when we divide, if you multiply or divide by a negative number, the inequality sign will change. Here we divided by positive pi, so the inequality sign did not change. Here we are subtracting by a number that does not change the inequality sign. I'll multiply this. Now I have my k between this and this. Is that okay? From there, I'll have, you divide this by this and this by this. You have k between this. You then represent it on this number line. This, you are supposed to do it on your rough work, not on this paper. You draw it on your rough work. You represent your numbers for you to easily see the integers that you are supposed to take. From there, I easily see that the integers I'm supposed to take are what? -2, -1, 0, 1. Is that okay? Because the integers, this our interval says that we are here. It is open here and close here. So the integers we are supposed to take must be inside here. And the only integers are -1, -2, -1, 0, and 1. So this implies my k must be this. Is that okay? From there, you start substituting. When k equals to -2, you go and substitute it. You substitute it inside here to calculate. You have the first one. When k equals to -1, you have it. When k equals to 0, you have it. When k equals to 1, you have it. Then you then conclude for x being equals to this, the solutions on this interval are, you just take your solutions from the negative values to the positive ones. So this, and this. Is that okay? You do the same thing. After finishing this, you do the same thing for this one. So for this, you recall this, you find the interval of k as we just did, and you also find the solutions that satisfy this. You find it. Now the general solution, the final solution, S will be S1 union S2. I said union. Why? We use union because when we are working in the when we're working in the general solution, when we're given the general solution, what did the general solution say? The general solution said that x equals to this, or we know that in mathematics or means union. So that's why I took the solution of this union, the solution of this. Is that okay? So from there you will have the final solution. So that's simply how you do that. Okay, see you in the next video, because this video is already a bit long. See you in the next video for me to do the next exercise.